Okay, so for the first example, let's start with step one and let's read it. Right. So find three consecutive integers such that they add to 57. Okay, now at this point, you'd want to read it more carefully. I've already done this ahead of time. So let's just point out what I noticed in my thought first time. So we know that we have three consecutive integers. Now, consecutive just means that it's one after the other. So 1, then 2, then 3, those are consecutive. 15, then 16, then 17, again, consecutive. So we just want to find three consecutive integers that all add to 57, right? So we're going to end up at some point adding them up. So that's what that tells me. Now, this isn't talking about a physical object, so I'm going to skip step 2. I'm not going to draw a picture. There's not a picture to draw. Step 3, there's not um, there's not really any values. It didn't tell us that one of the numbers was 15 or something like that. So we don't have anything like that. So let's go on to the next step, which is consider the equations. Now this is what makes this problem interesting, is that all they gave us was equations. They didn't really give us any values. So let's write down the equations that we have. So let's just say that these three integers are x, y, and z. Now we want to sum these three integers so that they add to 57. So we're going to have x plus y plus z equals 57. That's the first equation. Now, this the other equations they gave us all come from this word consecutive. Now remember, that means one after another. Right? So if we say x is the smallest consecutive number, that means y is one more and z is two more. So that means is y is x plus 1, z is x plus 2, right? So now you see that these would be consecutive. You'd have x, x plus 1, x plus 2. So if we take these two equations and we plug them in here, we'll have x here, then we'll have plus, but instead of y, we have x plus 1. Then, instead of z, my bad, we're going to have x plus 2. And the reason we did it like that is because in order to solve this type of equation, we're going to need to isolate those. We're going to need to get like only one variable per equation. Right? So here there are three variables, meaning we can't actually solve it. But when we plug in these two equations, we only have one variable, x. So that's why we did it like that. Now, we're going to continue solving it. Right? So we have three x's here, 1, 2, 3. So this becomes 3x, and then we have a 2 and then a 1. Add those up, we get a 3. So 3x plus 3. And then that's still going to be equal to 57. Now, at this point, it just comes down to solving for x. So if I subtract 3 from both sides, I'm going to get 3x equals 54. And then I divide both sides by 3, I'm going to get, I'll write over here, what's 54 divided by 3? That's going to be 18. So now we know what x is. We know that x is 18. Now because they're consecutive numbers, that means the three numbers we have must be 18, 19, and 20. And that right there is problem 1 solved. So now let's move on to problem 2. This one's a bit trickier. One number is 9 more than 3 times a number. If these numbers add up to 29, what are the numbers? So, let's say that our two numbers are x and y. And let's do a second reading of the problem, like before, and see what we notice. So, we know that one of our two numbers is 9 more than 3 times another number. So what that tells us is that we're going to be taking one of our numbers times 3, that's what 3 times mean, and then plus 9, 9 more. Now, if these numbers add up to 29, what's that telling us? That's telling us we just take our two numbers, x and y, we add them up. So, now that we have an idea of what the problem is we're looking at, let's start to assign values and write up equations. Again, this isn't a picture type thing. There's no concrete object that we're talking about. We're just talking about numbers, not assigning those numbers to any objects. So, no picture. There aren't really any values that we know, right? It doesn't tell us that x equals 80 or something like that. So, we don't know any of the values. So step 3 we can sort of skip over. Step 4 though, think of equations relevant to this problem. We can think of a few equations. Right? The easier one comes from the second sentence. The sum of these two numbers is 29. Right? So x plus y equals 29. That's one equation. Now, the first sentence here has a slightly more difficult to read equation, but it's there. One number is 9 more than 3 times a number. So, let's say y is the one number, and then the other number is x. It doesn't matter which one's which since you're making up the variables, but let's just be, for the sake of consistency, let's say that. So, we have 3 times a number, so 3 times x, and then 9 more than that, so plus 9. That's it. So we have our two equations. We have y equals 3x plus 9, and then we have x plus y equals 29. So, just like the previous problem, we can't solve any of them as is. Instead, what we need to do is we need to get rid of one of our variables in one of these two equations so that we can solve for the other variable. Right? Now, the way I'm going to do that is I'm going to plug in this equation for y right there. So instead of x plus y, we're going to have x plus 3x plus 9 is equal to 29. Now from here we combine like terms. X plus 3x, that's 4x plus 9 equals 29. Now we can just solve for x. So subtract 9 from both sides. That gives us 4x equals 20. And then we divide both sides by 4. That's going to give us, down here, x equals 5. So we know one of the two values. Now, we want to find the other number as well, y. So what we do is we just take one of these two equations and we plug in x. I'm just going to plug into this equation right here. It's slightly simpler, right? So instead of x plus y, we're going to have 5 plus y equals 29. Now to solve for y, all we got to do is subtract 5 from both sides. So 29 minus 5 is 24. And you see, now, we have our two numbers. We have 5 and 24. So this is the part of the video where we do all the more abstract word problems that don't have pictures and stuff. Now I'm going to get into some of the more picture-based problems.